Hi. Well, this repair video has taken a while. It's been 3 months since I uploaded the teardown and part 1 repair of this Haefely trench ESD 1600 gun, ESD tester gun. And then I did actually post a part 2 of this where we actually discovered that the fault was this special snowflake rotary encoder here. It would only operate in one direction, and so it would only go down, I think. It wouldn't go up. And of course, this has a digital readout. You can adjust it from 2 kilovolts up to 16 kilovolts output. And it worked. The gun actually worked, but I couldn't get it above the 2 kilovolt. Anyway, I'll link in the video up here and down below if you haven't seen it. And also an interesting follow-up video of a teardown of the actual rotary encoder here, which is a really unusual type. It's not your usual rotary encoder. So I won't go through the details again. You can watch that video. But anyway, this rotary encoder is only a single source. You can't get it anywhere else. But I found a company in Germany on eBay that sold like new old stock of these, and they sold them 2 at a time at a reasonable price. So I ordered them straight away, and a month went by or something and I didn't get them. And well, I'm mucking around and trying to trace it all. It turns out, nope, lost in the post. So completely lost. So I just ordered 2 more of them, and they did turn up, and I'm back from holiday. So now I actually got these this time. So I've got 2 of these bad boys. So let's actually take a look. You can see here that there are single pole double throw here either side, and each side here operates in one direction only. So this is the common here. So it'll toggle between these 2 pins like this when you rotate it in one direction, and if you rotate in the other direction, it doesn't do anything at all. It'll just stay there. And likewise, this one here will toggle between those 2 pins as you rotate it. So let's actually connect this up. I think this one is that one's normally closed. So let's actually rotate this. I'll go counterclockwise like that. It does nothing. Counterclockwise according to the bottom, but if I go clockwise, bingo, there you go. It does the business, and that other pin that'll just be normally open, and that one will close when I go in that direction. Well, no, occasionally it stays on, I think. No, it should, or shouldn't, not sure. No, it shouldn't. But even if it does accidentally stay on, anyway, it's the impulses that matter that the microcontroller's looking for. So let's try the other pair over here like this, and normally closed, and if we go in the counterclockwise direction, it is beeping, and go in the other direction, it's not. And the other pin, counterclockwise direction, yep, it goes like that, and Bob's your uncle, no worries, works a treat. So this should fix the gun. Right, so here's the PCB that we got out of this thing, and if you saw the teardown video, it's really annoying because I had this metal plate with all these switches on it, and had to desolder all of those to get in there to the digital pot. Where is it? It's up here. So have all my holes been sucked out? Desolder that one's a bit how you doing. Might have to open up that one a bit, but anyway, let's see if we can get that back in there and resolder that sucker. So yeah, unbelievable. A special snowflake. Wouldn't it be my luck? Murphy, of course. This used a special snowflake thing that's available from one source on eBay in Germany, new old stock. Yeah, it's just nuts. Yeah, of course, ultimately, if I couldn't get it, I would have designed a little plug-in board or something that just converted a regular rotary encoder encoding scheme into this encoding scheme, and it wouldn't have been too hard. In fact, that would have been an interesting video, but I was able to get this. Let's just re-suck that one, shall we? Beautiful. Look at that. Bobby Dazzler. Classic solder sucker. There we go. Got it. Got it. Sorry, zoomed in. Solder that back in place. Bob's your uncle. Look at that. Oh, hang on. One of the pins didn't make it. Oh, are you kidding me? Oh, did I bend one? Oh, wah. I just soldered. I should have checked. I just soldered all 4 of those. Oh, bloody hell. It's not even Monday. Yeah. Look at that. I squished it. Oh, unbelievable. I thought I had it in. Ah, that's what she said. Luckily I do have a spare, but I might get one more shot at this. Oh no, oh, it's floppy. That's what she said again. I'll have to watch the teardown video again, but why they manufacture this with 2 soft little piddly pissant pins and 4 big thumping solid machine ones, I'll never know. But anyway, oh gosh, try it again. I've probably got one shot at this. Always double check before you stick your pins into the hole. Once again, she's saying a lot today. Oh, that, okay. That when I did not put any pressure on that time. I did not put any pressure on. And, oh, I think I see 2 pins. Winner, winner, chicken dinner. Okay, you can see them. There, and that one there. You were probably all screaming at me before, right? Because oh, there we go, because you saw it on your whiz-bang screens you're watching this on. Sorry, I got to put this on and I don't know, I can probably use my 3rd hand. 3 hands on a pivot here. No, I couldn't be bothered getting out a holder. 1 pin there. Okay, I'll get this bad boy over here. There we go. That's one of the pins over there. No worries. And that is the other one there. Ooh. You can rotate the board easily when you've got it sitting on just a shaft like that. Once again, that's what she said. And sorry about the contrast here. It's always a problem. Contrast when you're trying to record video like that. And yeah, I got the fresh rosin fumes. Anyway, there you go. So now it's in. Unbelievable. But there you go, 4093 classic for the win. Now I'm going to make sure these pins are not. No, these are pretty solid. They're solid as. They should go in. Hopefully I've got. It's hard to tell where the holes are, but yeah, there, and there. They all look good, don't they? So I should be able to. Problem is, you got to line up. You got to line up 12 pins perfectly before it all drops into place, and they're attached to this side. Like they're attached to this side, so you've got to like. This is the only way to do it. Like, what engineer is responsible for this horrible abomination of an assembly process? Nah, that's terrible, Muriel. And they wobble from side to side. That's why it's not going in. Oh, and that one's pushed out. Like, oh, no. Can I actually take that? I think I can. Yeah, I can take that out. I can take that out and push it in later. Push them all flush. Oh, yeah. Yeah, some of them have come out, so let me push them all flush. Yeah, look at that. So they're all flush now. I don't know why some of them have this little plastic ring on it. Doesn't seem to be insulating anything of note. So, I don't know. There you go. So what you got to do is you got to give a wiggle, 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 yeah, to some of them before they'll go in. There we go. That's the trick. I'm ready for my job at the Haefely assembly line. 2 pins. Okay, they don't go all the way. Okay. Oh, that metal plate. I don't know whether or not the metal plate's supposed to sit on those spacers or what. Don't know what the deal is there. Rather unusual and annoying construction, but my pins are all the way through, right? So as long as those switches are push flush with that and I eyeball them that they're all good, don't know what the metal plate does. Does it just flap around in the breeze? That one there's that one there's higher than the other ones. So what's going on there? Oh, it's the plastic spacer. Okay. I'm not entirely sure what the height's supposed to be. I might go check the fit in the front panel. I don't think it's going to matter. Actually, yeah, it's not going to matter at all if like one of them's sticking up slightly more than the others. It's just rather annoying. Like, because some of them have that plastic spacer and some don't. So, I don't know. Not sure what the deal is. Maybe I can just pull them up to align them all at the right height manually. All right, I think I've got that, so that's going to be good enough for Australia. So let's go in here and resolder these. I know I should not be on the side like that. I should have flipped it around like that because it had the elongated pad, and that's just the correct thing to do. Don't you hate it when your solder bends like that? And a bit extra there for the ground plane. Don't pay the ferryman till he gets you to the other side. Alright, we are good to go. So, I will now reassemble the whole kit and caboodle. And this pot should magically work. I can't just power this up on its own. It's got to be all sort of like hand assembled before you can fire up anything. It's a terrible design, as you saw in the teardown video. Okay, now I have to remember how this all goes back together. All these loosey-goosey wires here, they solder onto points on the main board, I believe. I do have a post-it note somewhere. I recorded it when I tore it down, so let me find the details. Okay, so this has a board-to-board interconnect which goes in there, and all these wires are out of the way here. And then we've got some solder tags here as well. They have to be, no, they go back in with screws. And then there's spacers as well. I've got all my assorted bits in here. I just have to remember, it's been 3 months. I have to remember how they went back on. Maybe I should have documented it a bit better, but she'll be right. Check it out. It's pretty horrible. You've got a board which sits on a right angle spade lug soldered onto the chassis like that. And then this spacer here is supposed to go in there like that, and then you're supposed to screw it in from the front panel. It's just awful. I'll show you, this is truly horrendous. It really is. Like, I've got one in, but then the other one barely lines up, and you've got to try and, but I can't. It doesn't go back. It doesn't go back. It's in and under, in and under. Don't design your products like this, kiddies, please. This is ridiculous. No, you've got to manipulate that until that lines up there. It all hinges on this bent spade lug here. And no, the board's come out again. So now I've got to try and get the, no, line up all the pins again because there's too much solder on there. It's a nightmare. No, I'm going to have to bend that spade lug more. This is ridiculous. This is the worst physically designed product I've ever seen. This is just insane. And all the while, I've got to be careful not to, like, bend the pins. Thankfully, it's a double row. They're fairly solid, but, you know, you could easily bust one. Maybe I can cut off a bit of the solder there. Be less thick. Now, here's where you want a pair of reverse flush cutters. Like this. These are reverse ones. So that should allow me to get in there and just trim off that solder a bit so that board fits in there a bit better without me having to attack, like actually resolder the stupid thing, because then it'll all come out of alignment. So there you go. So I've trimmed off some solder on there. Sorry, not getting the best camera angles here, but hopefully you're getting the idea of what a real pain this is. A lot of excess solder on there. So, yeah, that should give me a bit more margin, because I was really pushing that board across to fit in the socket. Oh, that goes in the socket much easier now. Yep, I'm liking that. Hey, I think I can see the hole now. And after all that, I just realized I've got the wrong spacer on here. The wrong spacer. I have to put a screw from the back there. And not that hasn't caused me much grief, but it is a pain. So what I need to do is get the screw through there and then get the spacer. There we go. Got the spacer in there like that. And then that goes back to, doesn't quite line up now. Aha! I just realized I should watch my teardown video. Maybe I can realise how it went in. That is spaced off there because the PCB slides under there. So I was flogging a dead horse before trying to get that in. So yeah, there you go. That's the trick. But now I've got the problem of trying to get the board-to-board interconnect in there and slide in it under there at the same time. Okay, let's get this board in here. Lines. Whoa, the first pin's a bit, how you doing? How about that? It goes in. Aha, yep. I think I got it. Yeah, let that be a lesson to you. Document your teardowns a bit better. Or watch your own teardown videos and maybe it's in there somewhere. But we're good. We're good to go now, I think. Put the spacer and the LCD back on. And last screw for the LCD. Turns out I didn't have to take that off, I don't think, to get the board out. But didn't know that at the time. It's actually easier once you've done one of these once. as is always the case. But yeah, no, doesn't excuse this horrible design. Now comes another really tricky part. I have to actually, you can't see it, but that is a 4-pin connector, and this brown wire flapping around in the breeze has to be soldered on that rear pin right down in there. What a nightmare. So I almost have to flip the whole thing out, solder it in, and then sort of flip the whole thing back in, I think. Yeah, so what I got to do is kind of like flip this whole thing out. Then I can access solder that pin down there, and then I can flip it all back in, and this spacer has to go between the boards there, but I can take that out from the other side, so that's not too much of a drama. It's not pretty. I'll get back to you. This is where the long pair of needle nose pliers comes in handy, and we'll get that black wire in there. Don't burn any of the buttons. Been there, done that. Any bit of surrounding plastic, and there we go. Threading a needle. Wow, got the trigger button, and then there's just enough. Hopefully, this sits in there properly. There's just enough lead length to solder on. Sorry, you can't see it, but solder on the output terminal. Yep, there we go. And that is some surgery. The front panel, that just sits like that. They actually go into self-tappers into the plastic. Oh no, I forgot the stud up here. There you go. So I've got to put the stud back in. Oh no! Oh, did I forget? I think I forgot. There is a giant stud which goes through here. Like this. Oh no! And I've got to somehow screw that back in. This just gets better and better. Oh. Yeah, needle nose pliers again. Yeah, I can remember this from the teardown. I had to get that out before I could get the board and the chassis. Or the chassis out and then the board's out. There is a special place in hell for whoever designed this. Actually, before I get this back together, I've plugged it in. So no touching of any of the scary bits, of course, but operate. There we go. Ta-da! And let's see if it goes up. It does, it goes up. Yay! Oh, sorry, it starts at 200 volts, not 2 kilovolts. There you go. Works in both directions. Winner, winner, chicken dinner. Well, haven't tested the sparks yet. Can't do that. You've got to hook up the grounds and everything. And with enough patience, you can actually get that in. Oh, man. I'm sure you get used to it at the factory, but that's ridiculous. There's got to be a better way to do that. That's just crazy. Anyway, that is one of the studs. Like you can hook the ground up to either that stud there or that one there. It's all connected via the same chassis. But yeah, that's just crazy. There we go. tight as a nut's nasty. Okay, the last thing I want to actually repair in this thing is the nickel metal hydride batteries. I think I said NiCad in the previous video. They are actually nickel metal hydride, made in Japan. All the best stuff's made in Japan, and yeah, they've come a gutser over the years. So we've got that's a 6 series cell design, and it does have a little thermal fuse in there. So I'm not going to crack open my pack and actually replace that. But anyway, I've got a nickel metal hydride 2200 milliamp hour 6 cell pack, and they're just like dodgily soldered onto there. So I will just, and that's a temp sensor down in there. So I'll just cut a hole in the top of that. I'll stick the temp sensor down in the middle, and I'll just cut these off and bodge them in. So yeah, nothing much to it. Well, wasn't entirely straightforward. Did have to dig that out of there, but there you go. So there she comes out. I'll just stick that down the clacker of the new pack. No worries, she'll be right. There we have it. I'll just manage those cables in there. Now, the interesting thing is, this is already charged up. So, you've got to be careful when you're soldering these in, not to touch any of the high voltage stuff, because technically, you could turn it on. Let's try it. Yay, look at that. Works. Fortunately, it's only set to 200 volts, but, you know, never be too careful. Anyway, I'll put the cover back on, and Bob's your uncle. We'll test her out. Let's put the nylon spacer screws back in. You use nylon screws, of course, because you don't want any exposed metal on your 16 kilovolt ESD generator. Because, yeah, you could come a gutser, and that could ruin your day. Unfortunately, our calibration is now void. Gosh darn it. Though, they do have plastic self-tappers to hold on the outside thing here, but no worries, because, well, it just goes into the plastic case, and it's all on the low voltage side anyway. So I'll just turn that back, let it drop in place, find the thread. So pro tip, with metal screws into plastic, just rotate it back until you find the point where it slightly drops in place to the existing thread, and then you can screw it back in, and then you're not cutting a new thread in your plastic. But you don't want to over tighten that. There you go, look at that. Like I bought one. Now, please excuse the crudity of the model. Didn't have time to build it to scale or to paint it. I'm going to use my trolley here. I've got my ESD, my now functioning ESD gun. Look, it's actually functioning with the battery now, so I can actually turn the wick up and down. How novel. So yeah, I've got my grounding strap. It's going back to my power supply over there, and the trolley's connected over there. Yeah, it's not exactly an IEC 61000-4-2 standard setup. Leave it in the comments down below if you want me to, and I probably will anyway, but definitely leave it in the comments down below if you want me to build a like IEC compliant, well, you know, one that's at least good enough for Australia, compliant bench for proper ESD testing, because we've got the proper gun, we've got the two different adapters. This one's for an air gap, the rounded tip is for the air gap, and the pointy one is for direct contact measurements. But yeah, we can actually design and build like a compliant bench, at least for like pre-compliance purposes. Anyway, leave it in the comments down below if you want to see that, and to actually measure the output from this thing, actually get a proper waveform and actually check the compliance of this thing, you need what's called a Pellegrini target, and it's basically a 2 ohm, a proper coaxial to a high frequency coaxial 2 ohm test target, and it's also defined in the 61000-4-2 standard as well. So yeah, you know, it's like if you want to do all this ESD stuff properly, there's a lot of stuff involved. You have to get really serious. But anyway, let's just try the trolley. Let's just get something out of this thing. So let's turn it up to L3, 8 kilovolts here. We've got air discharge. We've got single here. Of course, we can set, you know, repetitive stuff. But anyway, let's just go for an 8 kilovolt. Okay, let's see if we can zap these capacitors here, shall we? We may get some noise into the microphone cable, but well, we'll give it a go. Geez, it's hard to reach over the camera with the macro lens, but give it a go. Zappity-doo-dah. Cool, huh? So there you have it. There's a repaired Haefely Trench ESD 1600 gun, and this is a real proper industry standard bit of kit for compliance testing. So that was absolutely fantastic. All it cost me was basically just the rotary encoder here and bit of frustration taking it apart and putting it back together, but no, that's a Bobby Dazzler, and I have no doubt that that actually meets its, would continue to meet its spec. But as I said, to get a proper waveform measurement out of this, you have to have a proper high frequency 2 ohm low, which is called a Pellegrini target, and you've got to set it up specifically, and even this cable, like, you can't just leave it flapping around in the breeze. You've actually got to, you know, pull it back, stretch it back so it forms like the largest loop possible, and like, it's really serious stuff because these impulses are really high frequency stuff. So, you know, the actual targets you use and the probing and everything else has to be really top-notch stuff. But yeah, I trust that this thing would still deliver its proper designed pulse response shape, which would be, you know, match the industry standard shape. But there's many different aspects to ESD testing, which is part of it's just one part of EMC compliance, the ESD testing, but it's all in the standard and it's very involved and quite complicated. But give this video a thumbs up and leave a comment down below if you want me to design and build a proper ESD testing bench. I'd have to do it down in the dungeon. I've got room in the lab for a small bench, but you know, it's better off building it down there and yeah, setting it up properly and maybe even getting some waveform trying to get some proper waveform measurements out of this thing anyways. But as always, give it a thumbs up, discuss down below, and also on the EEVblog forum. And I do release all these videos on Twitter/X now as well, so you can follow me over there. And EEVblog.com for the merch. Catch you next time. I can make these capacitors sing. Listen to this.